Hey, there were a few things that came up in the review session I wanted to make sure everyone was really clear about, so I just thought I'd mention it in a very short little video. In chemistry, we are usually most interested in the valence electrons because they're the ones that do all the chemistry. They're the ones that are in the outermost energy levels. And the core ones are the ones that are inside. They're the ones that are closer to the nucleus. And I don't mean that they're inside the nucleus. I'm just saying they're more inside, whereas the valence are the outside. So when we're looking at lithium right here, I've got two S block examples. And by S block, I mean that their valence electrons end at the S block. Or you could say that when you're doing the electron configuration, you're stopping at this spot and this spot, which matches with the S block. In that case, what you want to do is you want to look for the highest energy level. So like this would be the highest energy level, basically the highest big number. And like this one over here this is the highest big number. And notice there's only one in this case of each of those big numbers, that's fine. This guy would have one valence electron, this guy would have two. All of the other electrons would be the core electrons. So this is a core electron, and all of these guys are the core electrons. So notice valence, and then the rest are core. And then we have our P block, and we're going to do the same thing with the P block. We're looking for the highest number. So like there's 2 times that this is the highest number that occurs, and right here that occurs twice. And then over here we also have the 4, and that's the highest number, and it occurs twice. So we're going to pick our valence electrons. They're going to be the ones in the highest numbers. Those are the core. Those are the valence. And these ones are the core. You would just add them up if you were asked the total number of core electrons. Now, there's going to be something that's a little bit different for the D block, and that's because in the D block, the outer electrons are in very, very close proximity. So this guy right here and this guy, they are very close. It's not an issue up here. It's not an issue. He's not close enough for you to end up pulling anything out of the D, but these ones right here are very close to each other. And so in the case of the D block, and again, I'm saying D block, and this is also all according to OpenStax, there is some debate out there as to whether or not we should call the D electrons valence electrons or not. So in our OpenStax book, we do call them valence electrons, and so that's what we're going with. You remember, you always would take an electron out of the 4s first, and then you can take them out of the Ds. So then you have your core electrons, and they're in all of the rest of them. Something else to note about the valence electrons, or this valence electron position, especially for the P and the D block, is that when you need to remove electrons, they come out of the valence electrons. And if you're going to add electrons, they go into the valence locations until they get full, and then they'll start the next energy level. So like for right here, the D block and the S block, those are both ones that are going to be losing electrons. So you lose here first, and then you lose from here. Again, you lose here first, and then you're going to lose from here. And then up here, you're going to lose here first. And usually they don't actually lose anymore. It would be really energetically unfavorable to do that. And then with the P block, now the P block likes to gain electrons because they're close to the right-hand side. They don't like to lose, they like to gain. And so they are going to be gaining into that section. And they're going to be gaining into the highest one, so they're going to gain here. They can't gain here because that's already full. So again, this will gain here, and you're going to gain over here. Again, you won't be gaining here or here because it's already full. And last but not least on the same topic, the idea of para versus magnetic. So para is when you have unpaired electrons. So for example, lithium, you can see it right over there. He's got an unpaired electron. He's right there. He's got an unpaired. So he would be para. Carbon has an unpaired electron. Phosphorus has an unpaired, at least one. You can have multiples. Arsenic has unpaired. And over here, you'll notice that we've got not only an unpaired S, but we also have unpaired Ds. So he is paramagnetic. And then also we've got the unpaired Ds right there. So look at how many paramagnetics there are versus diamagnetic. And when you are paramagnetic, that means that you are magnetic. The diamagnetic, what we say is that it repels a magnetic field, or if you're being kind of just general about it, you'd say that it is not magnetic. Okay, so another thing that came up was about the energy of the electrons, and so we don't have to know how to calculate the energy of each energy level. You know, you don't have to use that equation with the the negative b times the z and then the 1 over n final squared minus 1 over n initial. You do not have to know that. But what you do need to know is that when you are going like this out, that is absorbing energy. So like what happens is that light hits this electron and he gets all this energy and he goes out. Or if you were looking at it with the little energy levels, like that would be 1, 2, 3, 4. When this electron goes up, that's absorbing energy, absorbing. And then when an electron that has, absorbed energy, so that would be like a little hole area or a little spot. Didn't mean to erase that much of it. But when you have like a little hole right here because the electron absorbed energy and it was sitting up here, when it comes down, what comes off is the emitted energy. And that's what we see if it's in the visible range. Notice that they can choose to just come down one level, or like if it's really high up, they could come down in pieces of levels. The other thing you want to make sure that you're very clear on is that absorbing energy, that is a positive energy. So it's when you're going from a lower energy level, let's say 1, to a higher, say 2 or 3 or 4. And then emitting is a negative, and that's when you're going from a higher to a lower. And so that'd be like, 4 to 3 or 4 to 2, something like that. And you want to notice that the spacing between these energy level changes, and we've mentioned this. So this is a larger amount of energy than like up here. That's a very small amount of energy, smaller. So it takes less energy to jump between those outer energy levels than it does to jump out of the inside energy level.